Yeah, this is a useful demonstration on how much electricity are consumed when one created and watch only one YouTube video. And then imagine that there's a enormous amount of clips and videos that produce and store in YouTube. And not only YouTube, there are many other streaming and video producing platform nowadays like Vimeo. So you can imagine how large it is. The electricity has been used in this portion. And the second concern is the data center. And you can see here is in the screens an example of like a warehouse scale computer data center from Google. So for one data center, it have the scale of factories. It's not smaller than that. As you see, this only for in the screen is only the small part of the area is already like a huge building. And imagine that inside these buildings you have many servers. So servers are computers. It is more powerful than your personal computers, and they are built to do a special task. They can be strong on, I mean, computing or storage. So Amazon, Microsoft, and Google accounts for more than half of the world's largest data centers. So in 2021, it's reported like 2,670 data centers located only in United States. Amazon has more than 50 data centers and they continue expanding globally. Google has around 21 data centers locations and they have about 900,000 computer server. Um, this report has been presented some time ago, but it still hold true until today. Researchers and the practitioners look into possibility sustainable challenges with a data center, and they can see that here on the top in the chart, the heat, the density, and cooling is the most uh, concerned issues is taken by 22% of people who are surveyed. And space constraints and growth is taken 90%. And the third one is about power or electricity densities. So the out of the top three issues with the data center, two already regarding about like energy consumptions, how we can use energy efficiently to manage the heat and to cool the system, and how we can balance the power densities among the data centers servers. Then the third part, after the compute-based systems and the data center, I would like to talk about the hardware, how hardware relevant to the sustainability. There's a life cycle usually when from the beginning when we want to build a hardware products until the time we get the hardware into the consumer and until they are disposing and recycling. And people throwing away a lot of like hardware devices that you see in the picture. So dealing with the physical artifacts, the whole parts of the hardware products devices is a big concern. Has a big environmental impact regarding the greening of IT sector. So we will go through the life cycle, and we can talk about how what are the concrete impacts when producing, delivering, using and deposing hardware artifacts. When producing hardware products like a computer, a laptop, or a mobile phone, it consumes the physical resource. It consumes minerals, like smaller and lighter components will use less material. But if you want the bigger computers or bigger phone, then it will consume more materials. And some material is a rare minerals. It is the amount of material is very limited in the earth. Energy is also needed to produce. Energy need to given to the manufacturers to create it and produce the products, right? And this process also emits CO2 and other maybe harmful, poisonous water or materials. And when the equipment or product is produced, they need to be transported. A general problem and not only applied to the IT industries. And transporting is creating a lot of CO2. It can create air pollutions. It can create the traffic and trouble for road management, not only in the urban area but also rural area. And also fuel consumptions, that is mostly counts here, and what is most significant environmental issues for transporting equipments. We also calculate consider the wear on transportation infrastructures. And just suggestions how to reduce environmental impact. Yeah, you can two things, and the most important thing is to reduce fuel consumptions. So we can optimize the size and the weight of the equipments and be better with packagings and combining different packages, so to make a transportation, to make a trip become more efficient. The same trip can carry more and use energy efficient transportations. So it's reported that ship and rail, but not plane, which is the thing recommended to use for transportations. And reduce distance. So maybe have a strategy to be closer to customers. And after transportations, we care about like how to operating the equipments, and it's mainly care about the energies from the computer equipment elements to cooling. So we understand that data center is a part of this picture, right? That actually data center is the one that consume that significant amount of energies. IT sector is estimated to produce a 2% of the total carbon emissions. It's low share, but it's still a significant number, and it's always a wish to reduce this number. And yeah, we'll break it down. Smartphones, TV, and computers, and all other personal devices, they consume some amount of energies every day. When we calculate some number in term of in the national level or at the global level, we will see a huge amount. Let's see, when one smartphone, when you charge your phone every day, it consumes like from 1 kilowatt to 5 kilowatt per time. And let's think about 3 billion smartphones, and you should multiply this number with 3 billions, and you see not only how much energy but also CO2 consumption it can be generated with when we look at the global level. So here, to sum up the hardware part, I have present to you the negative impact when producing, transporting, operating the hardware equipments. Now we talk a bit about the disposing of the hardware equipments. There's a term that has been circulate a long time ago within the research community and in practice, the e-waste. So today e-gadget, today is a hardware device, and tomorrow they will become e-waste. So e-waste is an electrical or electronic equipment that are discarded. So this includes both like working and broken items that are thrown in the garbage or donated to a charity's reseller. So you can include not only phones, laptop, desktop TV, printers, scanners, but also like household gadgets like microwave ovens, toasters, and etc. So you can see the list in the slide. And European Union expected estimate that they will generate around 12 million tons of e-waste yearly by 2020. And in a global scale, the estimation of 50 million tons will be generated every year. And there's a lot of issues with e-waste. Not We do not repeat this, but we know the energies and fuel consumption for transporting them, for processing them, the waste deposit in landfill, it will probably ruin land, water, and natural resource. Integrated circuits, which is often found in e-waste, often contain hazardous metals like lead, mercury, and that have to be managed, handled. Touch screens may contain also poisonous parts, and these all dangerous chemicals and materials can also be harmful to people who living around or who processing, who working with the disposing tasks. And in Norway, disposing e-waste is free, and you can find Station. Some is yeah, central that they can accept the e-waste and handle it. It is also a great initiative in European Union's countries to deal with e-waste and to manage them properly. But how it is going on around the world, in other parts of the world, how electronic waste are handled. And last but not least, I will talk about the software parts, the connection between software and sustainability and greening. To be able to operate the hardware device, you need the software part. Software is more like tangible. You do not see it. It's not a physical element, so it might also be more difficult to connect the concept of software to greening. besides energy consumptions. So I will, yeah, also still the main focus is on how to optimize and build a better, more energy saving software. Software always expands. It's not like hardware part. Software, we always produce, we always write more software. So the software will expand to fit its container. That's the law that we have found. So if you have a computer with 200 gigabytes, you will also consume this amount of storage. And if you have the computer with like 2000 gigabytes, you will also eventually consume all of this storage. So software and data over expand to fulfill its container. So we need to, and software is the data. Software and data will require energy consumptions for us to produce, to store, and to watch, and to read, consume, right? So it is big issues. Software is only limited by human ambition and expectations. We always find new algorithms, new application, better software, better, good-looking software, and a more interesting game. We always find a reason to create and generate a new, better software without thinking about the energy consumption part. We when talking about greening software, we talk about first the efficiency of the algorithms to process and to store the data in information for any given computing hardware elements. Algorithm can also be used to route data to data centers where electricity is less expensive. So this is also the way that using software itself to green the IT sector. The use of parallel and approximate programming, not requiring too precise computing, it might also significantly reduce the need of energies and increase energy efficiency. And computer virtualizations can assist in distributing work so that servers are either busy or put in low power sleep states. So again, using software to help to save energy when using the hardware devices. And one thing that we have seen as the missings in the software industries is the energy label. In the hardware industry, it is clearly showing how much energy has been consumed by a physical device. So you might or might not choose the device, the hardware products with better energy consumptions, but at least you are aware of the energy label for each of the products. We should definitely have something similar for software to at least make people aware of that software and also data consumes a lot of energies, and we should also promote and encourage for the buying, purchasing, and using of energy efficient software.